What if I told you a spacecraft that died almost a decade ago is still whispering secrets to us right now in 2026? And what if those whispers are quietly rewriting everything we thought we knew about life beyond Earth? Before you scroll away, do me one small favor. If space, mystery, and the truth about our universe excite you even a little, tap that like button right now. It tells YouTube this story matters. Hit subscribe so you never miss the next big discovery. And share this with one friend who still believes we are alone in the cosmos. Trust me, by the end of this video, they will not believe that anymore. Now let us go back to September 13th, 2017. A machine the size of a school bus was racing through deep space at over 70,000 miles per hour. Its cameras turned one last time. It looked at Saturn's glowing rings. It looked at the icy face of Enceladus. It looked at the orange, dreamy haze wrapped around Titan. And then it clicked the shutter for the very last time. 2 days later, that spacecraft was gone, burned, melted, vaporized inside a planet almost 900 million miles from home. Engineers hugged each other. Some cried. News anchors called it the end of an era. The files were locked away. The mission was stamped complete. The world moved on. But nobody told the world the truth. Those pictures were not the end. They were the beginning. Right now, in 2026, the images and readings Cassini sent back in its final hours are producing discoveries so wild that scientists are literally running out of words. We are not talking about a filter that made old photos look sharper. We are talking about brand new papers in Nature Astronomy and the Planetary Science Journal. Papers that are quietly flipping textbooks upside down. Papers that touch the oldest question humans have ever asked. Are we alone? And it all traces back to those final frames. Stay with me, because what Cassini saw in its last breath is only starting to make sense today. To feel why this hits so hard, you need to know what Cassini really was. It was not just a robot. It was not just metal and wires. It was the boldest planetary explorer humans had ever built. It launched in October 1997, carrying a smaller probe called Huygens strapped to its side. Then it did something almost unimaginable. It spent 7 long years sailing across our solar system before finally reaching Saturn in 2004. What came next was 13 years of nonstop wonder. Cassini snapped over 400,000 images. It looped around Saturn 294 times. By the end, it had traveled almost 5 billion miles. It found seas of liquid methane on Titan. It saw water erupting from the south pole of tiny Enceladus. It sniffed out the chemical ingredients of life inside those sprays. It mapped invisible magnetic fields. It flew through Saturn's rings. It changed everything we thought we knew about the outer solar system. Yet the scientists always warned each other about one thing. The data was so rich, so layered, so heavy with information that it would take decades to fully unpack. They just did not realize how right they were. Because what is pouring out of that archive today is not small, it is not gentle, it is earthquake-level science, and those final images sit right at the heart of it. Let me take you inside those last moments, because what NASA did with Cassini was genuinely one of the bravest things any space agency has ever attempted. By April 2017, Cassini was running dry, fuel almost gone. Engineers had a choice to make. They could let the ship drift and risk crashing it into one of Saturn's moons, possibly contaminating a place that might hold alien life. They chose the harder path. They chose the beautiful path. They designed a controlled death. But before the plunge, they gave Cassini one last gift. For 22 weeks, they flew it through a narrow, unexplored strip of space no human machine had ever crossed. A tiny 200-mile gap between Saturn's inner ring and the top of its cloud tops. Nobody knew what was in there. Nobody knew if the ship would even survive the trip. They sent it anyway. 22 dives, instruments wide open, cameras firing, every sensor screaming for data from a region science had never touched before. And then, on September 13th, only 2 days before the final crash, Cassini turned its lens for the last time. Enceladus, Titan, the rings, Saturn's blue and gold North Pole. It packaged those images. It sent them home, and they looked breathtaking. But behind the beauty, something strange was happening. The instruments that were sniffing and tasting that mystery gap were picking up numbers so weird, so unexpected, that many scientists first thought their machines were broken. Spoiler, they were not broken. Cassini was just seeing something nobody had prepared them for. Here's what was hiding in that little gap, and in those last transmissions that we are only fully understanding now. When Cassini slipped between Saturn and its rings, one instrument on board acted like a superpowered nose. It could identify chemicals just by tasting the space around it, and what it tasted made the entire science team freeze. Complex organic compounds were falling like rain from Saturn's rings into the planet itself. Not tiny, simple molecules, big, complicated carbon-based chemistry, and not a small trickle either. around 10 tons of material every single second. Scientists already had a nickname for this: ring rain. But the amount Cassini measured in that gap was on a whole different level. The rings are not slowly leaking. They are pouring themselves into Saturn. At this rate, the rings we love so much, the ones on every space poster in every classroom, could vanish completely within 100 million years. Let that sink in. The most famous feature of the most famous planet in our solar system is temporary. It is a short scene in a much longer movie. And Cassini's final orbits gave us the very first real numbers to prove it. But those organic molecules were only the appetizer. During those same last dives, Cassini measured something that sent physicists into a quiet panic. Saturn's magnetic field is weird, deeply weird. Every other planet in our solar system has a magnetic field that leans. Earth's magnetic north is not the same as its true north. Jupiter's field tilts. Uranus and Neptune are practically sideways. But Saturn's field lines up almost perfectly with its spin axis. The tilt is less than 0.1 degrees. That should not be possible. Standard physics says a magnetic field needs some tilt to keep itself alive across billions of years. A field that straight should shut down. It should not exist. Yet there it is, humming along, calm and clean. Cassini measured it up close during those final dives and confirmed it. The mystery only got deeper. Some scientists now think there is a hidden layer, a secret shell deep inside Saturn, canceling out the tilt we should be able to see. Others say our entire theory of how planets create magnetic fields might just be wrong. Either way, Cassini handed physicists a puzzle they will be arguing about for generations. If your brain is buzzing right now, hold that feeling. Because we are just getting warmed up. Quick pause. If your mind is already stretching, do this for me. Instead of the usual like and subscribe line, I want you to imagine one thing. Imagine that alien life is confirmed tomorrow. Where were you when you first heard the clue? Right here. So drop a comment with the word Cassini so I know you are with me. Smash that, so the algorithm shows this to more curious minds. And if you have not subscribed, now is the moment. This channel lives for stories like this one. Okay, back to the mystery. Because now we get to the hidden halo. In late 2025, a paper landed in the Planetary Science Journal that had been quietly cooking inside Cassini's data for years. It revealed something wild. Saturn's rings, the ones that look so flat and thin in every picture, are not actually flat. They are not even contained. During those final orbits, Cassini's cosmic dust detector picked up a ghostly halo of dust particles. This halo stretches up to 3 times Saturn's radius above and below the ring plane. 3 times. Think about that. This invisible cloud of material had never been spotted before because no telescope on Earth could see it. You had to physically fly through it to know it was there. And Cassini did. So the picture of Saturn in your head right now, the neat little planet with the thin, flat rings, that picture is wrong, or at least it is missing something huge. The real Saturn is wrapped in a ghost cloud of dust reaching into regions we never even thought to look at. We only know because Cassini brushed against that halo in its last months alive. But now, brace yourself. Because everything I just told you is small compared to what came out of the Enceladus data in 2025. This is the one that shook the world. This is the discovery that changed how humans talk about life in the universe. Enceladus is tiny. You could tuck it inside the United States and still have room left over. It is a snowball of ice orbiting Saturn once every 33 hours. When Cassini first arrived in 2004, most people saw Enceladus as a boring little moon. A footnote. Nothing to see. Then 2005 happened. Cassini flew close and spotted geysers, massive jets of water vapor and ice particles shooting from cracks in the South Pole. These plumes stretched thousands of kilometers into space. They actually fed material into Saturn's E-ring like a slow-motion fountain of a mini-world. And that meant something huge. Beneath that frozen shell, Enceladus had to have liquid water, a salty global ocean kept warm by the constant squeezing pull of Saturn's gravity. Year after year, Cassini kept diving through those plumes, tasting them mid-flight. It found salt. It found tiny grains of silica. That silica was a big deal. Silica of that specific size and shape can only form when hot water meets rock. That meant hydrothermal vents on the ocean floor of Enceladus. The same kind of vents that on Earth spark and support entire ecosystems in total darkness. Cassini also found simple organic molecules in the spray. Every finding was already amazing on its own. But then, in 2025, researchers went back to the archive with brand new tools, sharper software, better models, fresh eyes. And what they saw pushed everyone to the edge of their seats. A team led by researcher Nozer Kawaja focused on the freshest samples of plume material. The stuff caught right as it left Enceladus, not the older weathered dust drifting in the E-ring. That distinction had never really been made cleanly before, and it changed everything. because those young, fresh grains held molecules nobody had ever confirmed before. Esters, ethers, alkenes, compounds carrying nitrogen and oxygen. These are not random space chemicals. On Earth, esters and ethers help build lipids. And lipids build cell membranes. In other words, the walls of every living cell inside your body. Now pause. This does not prove life is swimming under Enceladus. Let us be honest about that. But it proves something almost as jaw-dropping. It proves that the chemistry deep inside that little moon is not simple. It is not sleeping. It is alive with reactions. It is producing the exact family of building blocks that on our planet lead to life. The paper hit Nature Astronomy in November 2025. The response was instant. One researcher called it simply phenomenal. Another said it was the clearest signal yet that Enceladus is not just wet. It is chemically ready, chemically hungry, chemically compatible with the biology we already understand. Co-author Frank Postberg put it in words so clean they almost hurt. Those complex organic molecules Cassini spotted are not scorched leftovers from centuries in space. They are readily available inside the ocean of Enceladus. Right now, today, read that again, the ocean is actively cooking these molecules. Whatever is happening beneath that ice is not old, it is not frozen, it is ongoing, it is producing complexity at levels we never expected this far from the sun. A tiny frozen moon may be running biology-friendly chemistry live and in real time, while we sit here on Earth trying to catch up. That is what Cassini's final signals were carrying. That is what took nearly a decade to fully decode. Now let me swing you to another moon in the same story. Titan, Saturn's biggest moon, bigger than the planet Mercury, wrapped in a thick orange atmosphere, speckled with lakes of liquid methane. For years, most scientists were sure Titan hid a deep, wide ocean of water under its crust, just like Enceladus, only larger. Then, in September 2025, a new study slammed the brakes on that idea. A fresh look at old Cassini gravity data suggested Titan probably does not hold that giant liquid water ocean. The inside of Titan is behaving differently than the models predicted. Stranger, quieter in some ways, weirder in others. This is what makes Cassini's legacy so powerful. It does not only confirm our dreams, it corrects them. It tells us when we are wrong. It humbles us. Titan is still one of the most fascinating places in the solar system, but it is fascinating in a way nobody expected. And we would not know without Cassini's numbers. Then there is Mimas, small, round, and famously scarred by a giant crater that makes it look like the Death Star. For years, Mimas was written off as dead. A boring frozen rock. No jets, no secrets. Then, in early 2024, researchers pored over Cassini's records of how Mimas moves. They studied the tiniest wobbles in its orbit around Saturn. And the numbers told an incredible story. Mimas has a hidden ocean too. A young one, formed maybe 5 to 15 million years ago. That is a baby in geological time. Nobody had a clue. The surface still looks ancient. Dead. Cratered. But the wobble does not lie. That little moon is sloshing on the inside. Liquid water is hiding under the ice of a world that looked like a dry stone. And once again, the data had been sitting in the archive for years, waiting for someone smart enough to notice. This is the pattern. This is the rhythm of Cassini's afterlife. You look, you find, you archive, you come back with new tools, and suddenly the same data whispers something new. Take a breath here. Because it is time for another quick moment together. Quick check-in. If your jaw has dropped even once so far, you owe this video a tiny thank you. Not a full one, just a tiny one. Double tap that like button in a rhythm. Once for the rings, once for the moons. 2 clicks, then leave a one-word comment telling me which discovery hit you hardest. Rings, Enceladus, Mimas, Titan, Halo, pick one. That word helps this video reach curious people just like you. Okay, deep breath. Let us keep going, because the picture only gets bigger from here. Step back with me for a second and look at the full mural Cassini painted. A giant planet whose rings are pouring themselves into its atmosphere. A magnetic field so straight it should not survive. A ghost halo of dust 3 times bigger than the planet. Not one, not 2, but multiple moons hiding oceans under their crusts. And on one of those moons, geysers shooting complex organic molecules into space. The kind of molecules that on Earth help build the walls of living cells. 1 spacecraft, 13 years of active service, 1 final suicide dive. And all of that inside a single archive that is still being read today. The mission technically ended in 2017. The discoveries did not. Governments and space agencies noticed. The European Space Agency has already tagged Enceladus as one of its top targets. They are studying a spacecraft that could land near the South Pole and scoop the plume material right from the source. NASA's Europa Clipper is already on its way to Jupiter's icy moon Europa, another ocean world. And it is using ideas Cassini basically wrote the rulebook for. The whole field of astrobiology has been reshaped. Scientists now speak of ocean worlds as if they are their own category. Enceladus, Europa, Ganymede, Titan, Mimas. 5 places in our own solar system where liquid water may be hiding. 5 real chances. Before Cassini, we had guesses. After Cassini, we have evidence. And the strangest part? Cassini was never designed to look for life. Its instruments were built to measure magnetic fields and chemistry, to map ring shapes and track atmospheric wind, to be a generalist explorer, poking at a system we barely knew. Nobody strapped a microscope on that ship. Nobody sent it to grab bacteria. Yet somehow it came back with molecules that build cell walls. It came back with proof of hidden oceans. It came back with rings evaporating in real time. It came back with a magnetic mystery. It came back with a dust halo the size of a small world. None of these discoveries were on the shopping list. All of them were quietly waiting in the data, waiting for humans to grow smart enough to see them. Now here is a thought that gives me chills every time. Scientists estimate the full scientific harvest of Cassini's data will keep coming for another 10 years, maybe longer. Every year, new papers, every new paper, new surprises. The spacecraft is dust. It vaporized in Saturn's clouds. But in a very real sense, it is still working, still transmitting, just slowly through the patient labor of scientists running new analyses on old numbers. Cassini's final images did not go viral because they were pretty. They went viral because of what was hidden inside them. Information we needed years to be smart enough to read. A message written not in ink, but in physics, in chemistry, in wobbles and dust and rain and rings and jets. Cassini saw all of it, recorded all of it, and now, piece by piece, year by year, we are finally learning to read the language. We sent a machine to the edge of our solar system, and it came home with the strongest hint in human history that we may not be alone. Let us go deeper into Enceladus for a moment, because I want you to see just how loud the signal really is. Think about what those new findings actually demand. For esters and ethers and nitrogen-oxygen molecules to be shooting out of a moon, the ocean underneath cannot be a quiet, cold, still puddle. It has to be active. It has to be warm in places. It has to have energy running through it. That energy is almost certainly coming from hydrothermal vents on the ocean floor, hot cracks in the rock spewing warm mineral-rich water. Cassini's earlier silica findings pointed there years ago. Now the fresh molecule data is basically screaming it. The floor of the Enceladus ocean is not dead rock. It is a living seam where water meets stone at high temperatures, cooking up chemistry nonstop. And here is the part that makes my chest tighten. On Earth, that exact kind of place is one of the richest habitats we have. Deep sea vents on our own planet swarm with life. Bizarre life. Tube worms as tall as people. Blind shrimp. Bacteria that eat sulfur. Ecosystems that laugh at sunlight. They do not need the sun. They eat the Earth itself. They live on chemistry. They live on geology. If that kind of life thrives at the bottom of our oceans, in complete darkness, cut off from the sky forever, then asking the same question about Enceladus is not science fiction. It is not a movie plot. It is a serious, sober, mainstream scientific question. And it exists only because Cassini kept sending signals until its final second. Time for one more moment together before I take you to the last piece of this puzzle. Small favor before I show you the most poetic part of this story. If you have made it this far, you are officially in the top 5% of viewers on this video. Most people click away in the first minute, not you. So do this. Tap the share button and send this video to someone who loves stargazing. Then hit that subscribe button if you have not already. Not for me, for you. So the next mind-bending story finds you first. All right, let us close this out the right way. Because there is one more thing about Cassini I need you to feel. Not as data, not as science, but as an idea. We built a machine. We poured our smartest minds into it. We packed it with cameras and sensors and dreams. We launched it into the sky. We flew it for 20 years. We aimed it at a world almost 1 billion miles away. And then when its fuel was almost gone, we programmed its death. We told it exactly when and how to end. And in its final weeks, in its final days, in its final minutes, it was still working. The very last signal from Cassini reached Earth on September 15th, 2017 at 7:55 in the morning, Pacific time. Here's the part that gets me every time. That signal arrived 83 minutes after Cassini itself had already stopped existing. Because that is how long light takes to travel from Saturn to Earth. For 83 minutes, Cassini was already gone. Vaporized, nothing left. And yet, on Earth, we did not know. Its voice was still crossing the darkness. Its data was still landing on our antennas, and the machine had already died and we were still hearing it speak. Sit with that image for a second. A dead spacecraft, still teaching us across nearly 1 billion miles of empty space. That is not just poetry. That is the truest picture of what Cassini has become. Even now, in 2026, researchers are still listening, still finding, still stunned. The machine is gone. But the knowledge it carried, packed into hundreds of thousands of images and mountains of readings, is still opening, still whispering, still shaking the ground. And what it is telling us about hidden oceans, about complex chemistry, about evaporating rings, about impossible magnetic fields, is extraordinary. So the next time someone tells you space is empty, remember Cassini. Remember the little machine that flew into fire so we could see clearer. Remember the silence of Saturn and the voice that still travels through it. Remember that somewhere under the ice of a moon named Enceladus, warm waters meeting rock and building the same kind of molecules that built you, Cassini did not close a chapter. It cracked open the first page of a much bigger book. And you and I, watching this in 2026, are only just starting to read. So keep your eyes on the sky, keep your mind open. Because the next signal, the next paper, might be the one that finally answers the question, are we alone? Cassini's final images did not answer that question. But for the very first time, they made it feel like the answer is coming. And it might come sooner than any of us are ready for. Stay curious, stay human, and I will see you in the next one.